All right, so let's take a look at how we interact with the with XML documents, in particular using the Java programming language. Now, this hierarchy of elements is also referred to as the DOM, or the Document Object Model, right? Meaning, at some points, some program is going to have to convert this ASCII code, right? This ASCII text file is going to have to read it and then convert it into some in-memory representation of that document, XML document. Yes, right. So the standard of is to give names to this, right? To have that call these elements and attributes and the actual data. And then create an object model representation of this XML document. Now the standard is called the DOM, the Document Object Model, right? And uses this nomenclature to refer to all these elements in this hierarchical representation of that ASCII or text file. And each language, Java, PHP, or Python, or whatever, any language will have a set of libraries, right, that will allow you to give it as an input an XML document and convert it into a DOM representation, right? Now, the DOM representation is a standard, right, that every language will implement using the same nomenclature, right, the same naming conventions. And Java is no exception. So as an example, we'll take this as an example input XML document, a list of students. We have at the top is the document descriptor, right, that tells us what the version of the XML file that is using this particular file, whether this XML file is meant to be interpreted all by itself, or if it has some dependencies with some other document, right? Perhaps you could specify here how could this XML document be validated, for instance, right? Oftentimes, I would like to be able to make sure that the XML document I'm looking at can be validated so that it has the correct structure, file structure, that the elements are spelled correctly, that the names of the attributes are spelled correctly, that the data types 1 to 3 is an actual number, that the values Alice, Wonderland, and whatnot, those are actual strings or dates or numbers or whatnot, right? That students these branches, the student branches, are actually correctly children of the students. Elements, that the root is indeed the student's element. So the schema, right, the XSD or DTD would specify all these things, right? That they have to have these particular names, all these tags have to have that particular name, the attributes have to have those particular names, those particular values, and the structure is correct, right? So that would be equivalent to a particular record or set of records that you intend to either retrieve from a database or insert or update into a database, that they are of the correct data types, and that the database will validate and make sure that you're not inserting bogus data, right? So that would be the equivalence here. So anyway, so here we take a look at some of the standards that every language will have to implement, right? Here we're going to look at specifically how Java implements it, but every language will have to make use of the standard implemented by the W3C consortium that provides certain interfaces, right? And they all have the same names, regardless of what particular language you might be using, and they have pretty much the same interface, right? So if you learn it for one language, it'll be transferable to some other language that will use the same identical interface. So here we have some of the nomenclature. We have document, note list, nodes, elements, right? So these node and note lists and whatnot, they are meant to represent any one of these nodes in this tree, right? Now, some of these nodes are of a particular type, right? For instance, if they represent a tag or an element, they are element nodes, right? Some other nodes are the attributes of an element. They are also nodes, right? So, for instance, when they're parsed here, these enrollments elements, they would be nodes in this tree, right? They would be element nodes. But the graduation year and the S name and title and grade and year taken, those also would be nodes. They would be attribute nodes, right? And they would be children of the parent course taken element, right? So because notice that the data here, the data of whether the grade that you got or the year taken, if it's information that is very short, like a number, like 2007 or B+, something that's very, very short, right? You could decide to either capture it as an attribute, like we did here, or you might decide to instead capture it as an element, like graduation year 2009. Right? If it's something very long, right, perhaps an essay or some large piece of information, or whether it's nested, then you would decide to capture it instead as an element, right, as opposed to an attribute. But regardless, both the attributes and the elements are nodes themselves. Also, some of these elements are collections of elements. Like for instance, graduating students has a list of nodes that live under it, right? So to represent this collection or array we have these node lists. Okay, so again, and document represent the entire document, okay, and the version of the document and any dependencies of this document with other outside elements. So those four classes or those four interfaces, document, node list, node, and element, those are part of the standard W3C standard on how do you interact with XML documents. So some of the other XML-related classes that are particular to the Java language are document builder factory and document builder, that allows you to parse XML document and generate these standard data types, right? So read or write back to an XML document. So here's a very simple example of a Java class that can read an XML document, in particular this XML document, the student's example. So everything starts in main. And notice that we are putting everything in a try-catch block just because we're going to be dealing with files and parsing and whatnot. So the first couple of things would be to create an instance of the document builder factory and then the builder. After that, it's pretty much the W3C API, right? But we first start with the Java specifics of grabbing a factory and a builder. We use a file to provide a reference of where the actual XML document lives, and we use the builder to actually parse the XML document. It gives us a reference to the W3C document instance, which then has an API that will allow us to navigate through this XML document, right? So very much like in a relational database at the command line, you would do select statements for retrieving elements or retrieving records, right? So in a relational database, you would say, select me all the records that meet this particular criteria where so-and-so this criteria. So very similarly, this API allows you to do the same thing. As you say, hey, there's this structure, okay, which is the equivalent of a whole bunch of tables, a whole bunch of records, yes? And I want to retrieve these records. I want to know, the grade that so-and-so got, this particular year, right? So I like to be able to query this tree. Very much like I can query a whole bunch of tables and I can join them, right? And the join is basically what? It's a hierarchy of multiple tables referencing each other, yes? The equivalent here is iterating over following certain paths across this tree. Right? I like to be able to query and say, hey, what did a particular student Ben got when in 2006 when they were taking Shakespeare. Right? So I like to be able to query this. Right? So these APIs allow you to query this structure. Right? Very much like you can query databases. Right? In a relational database, what you get back is a result set, which are perhaps a list of rows that match your criteria. Yes? Here, what you get back is a list of nodes that match your criteria. You say, retrieve for me all the courses that were taken in 2006. Right? And well, then it would be these courses, 1, 2, 3, these 3, or maybe that one too, right? So these 3 courses or 4 courses, regardless of where they are in the hierarchy, would return as one set of nodes, and all the courses that in 2007 would not be part of that node list. Yes, so the node list is kind of the equivalent of the result set, right? Of multiple rows that come back from a SQL query. So that API to query this structured data structure is all in part of the document, right? Of the document API, right? And all the elements allow you to query other elements that are under that particular element. Search all the elements that are under me, right? So in that sense, it's obvious it's much more hierarchical, right? That you can traverse this tree. So anyway, so this doc.get document element, meaning this retrieves the root, right? The root element at the very, very tippy top of the document. Normalize is a function that makes sure that if you have all sorts of white spaces, right, in the document that are irrelevant, right? For instance, all these tabs at the beginning, right? For instance, in front of student, in front of first name, in front of last name, in front of username, those tabs, or even the new lines, those are only there for our convenience, right? For frontal cortex, right? To be able to parse this visually, right? They're not really part of the data. Okay, so one of the things we want to do is just clean up the ASCII document with irrelevant data in there, right? Irrelevant new lines, irrelevant tabs, irrelevant white spaces. So what Normalize does is clean it off and says, well, just remove any extraneous characters that are not really part of the data, right? Just only keep the actual data. And then here we can retrieve the actual document elements, the root element, right? And get the name of the node. Again, this is standard W3C API. This is not Java specific, right? It's specific to the standard, and you'll find that it's the same API across multiple languages, right? It's the same API across. So this is you can reuse this in other languages. Here we're asking what's the name of the node, right? So you're getting the document element. In this case, is students, right? It's the root element. The root element students, and as part of a well-formed XML document, there's only one root, right? Of which then you have all sorts of branches branching off. So yeah, so we get students. Then we can start querying and says, okay, well, now here's an example of doing like a select statement. It says retrieve for me all the where clause. Here we're saying find me all the elements whose tag name is student. Right? Now that we know from the structure, that they are the second layer here, right? Off of the root, the students, all the student nodes are in the second layer right here. Okay, but our query is smart enough to traverse the entire tree. So no matter where the student elements occur in the document, it will find them. Even if they're nested somewhere very deep inside of the XML structure, right? It will retrieve all the elements and say, well, here they are. Here are all the elements whose tag name, right, are student. This is very much like saying, select star from student, and say, well, find me all the student records. In this case, it's the student elements. Yes. And then we can just iterate over them. Right? In our particular case, notice that we are assigning it to a node list, right, which is the equivalent of a result set or some result set in JDBC, for instance, right? In result set in JDBC is the list of all the nodes. Now, here is different. In a result set in JDBC, that one works a little bit different, right? It's actually returns for you some paginated version of the result set. So it retrieves only 10 or 20 or 30 rows at a time, because you're dealing with some potentially humongous result set of thousands and thousands of records. There's no way that it's going to instantiate this in memory. Here, instead, XML documents are not typically meant to have thousands and thousands of records. So these are actually the references to the actual nodes in the structure that has been parsed, right? So presumably, when in this parse here, when we parse this XML document, this is the entire document object model loaded into memory, having been parsed and all the instances of all the nodes pointing to each other, right? And then we have an API that allows us to navigate that structure. Okay? So this is somewhat different the way you would think of JDBC. Now, there are XML-based databases where indeed you could have thousands, millions of records, and in those types of databases, indeed the caching and the pagination would indeed apply. But here we're talking about some XML document, right, that we are parsing. All right, so here we are just iterating over those particular nodes. And you iterate just like you would if this were some collection or array. Here we can get the length, how many there are, and we can get each one of the elements one at a time. And then we can ask, since remember, node is a very generic type of data structure that we don't really know. It could be an attribute, or it could be an actual element. We can ask, what are you? Are you an attribute? Are you an element? What are you? And so and each node has its own type. We can ask you, are you an element? If you are, right, we can then cast it to the right data type of type of student, which is an element. And then knowing that it's an element, we know, oh, well, if you're an element, that means that you could have sub-elements. If you're an attribute, then no, you can't, right? An attribute cannot have sub-attributes. Right? An attribute is a leaf node, just like here, right? You have elements, like the student's element can have other sub-elements, whereas an attribute ID, ID is an attribute, cannot have sub-elements or sub-attributes, right? So attributes are by definition leaf nodes, right, where they're bound to a particular piece of information, and that is the information, the ID, the value of that ID. Whereas a student might have sub-elements such as first name. And first name in this case doesn't have any sub-elements. It just has a text sub-element. Right? So Bob would be a text sub-element. So there's three types of nodes, right, that we know of already. So they're either elements, attributes, or text, or actual data elements. So we parse, so we're checking, so we know you're an element, we cast you to an element. Now that you're an element, we know that you could have sub-elements. Right? You could have or maybe it's just plain data in there. Or you could have attributes, right? So we could say, get me the attribute. Student dot, the student element, get the attribute ID. So we can retrieve the ID attribute, the value of the attribute. We can also navigate to any of our children. So for instance, you can get elements by tag name. Again, this element by tags is fairly powerful, right? It can navigate the entire tree under us, looking for elements of a particular name, right? In this case, we're looking for the elements whose name is first name, last name, and username. We know there's only one of them. Right? We know there's only one, so we just retrieve the first item because that returns a node list, right? Get elements, it's plural. Get elements by tag name returns a node list, right, of a whole bunch of elements, of which we know there's only one named first name. So we could get the first item already, and we know their elements. We could check their type. We could check to see if indeed they are element nodes, but we can get lazy and just cast them because we know the structure of the document. Right? So here we're casting them. We know their elements. Notice that we didn't even bother to test. Right? So we're casting them. Now that we've casted them, and we know their elements, we can since we know that they don't have any sub-elements, we're not going to bother navigating them, right? We know that these are leaf elements, and they have just raw text as their body. Their body doesn't contain any elements; they contain actual text. So to do that, we can retrieve the text by just saying element.getTextContent, right, and retrieve the actual value of the first, last, and username, and then just print it out. Okay? Again, this is all very standard W3C, right? So this is not particular to Java or not. So let's take a look at another example. This is using movies. So we have movies, Blade Runner, the original and the new one. And so we'll retrieve from, presumably this is a snippet of IMDb. With the particular plot, poster, and title for those two movies. So here's an example of using the same code that we looked at earlier, and retrieving movies, elements, and then retrieving the IMDb, the title, plot, and poster, and just printing it out. Right, so if you want to play around with that. All right, everybody good? All right.